and we'll start ripping the machine to pieces. We'll unclamp the belt this end, and we will just loosen these lock nuts off on the tensioner, and that means these should then unscrew. And there we go. Now the only thing that's holding that whole head assembly on now are these 4 screws. Right, now everything now comes apart, and what we're left with is 4 screws that hold this head onto the bracket. I don't know how much that weighs, but I'm just going to go and weigh it. Well, the answer to that question is 130 grams. Here we are in pieces. All we've got to do is put it back together again now, and we should be building it back together with my new adjustable head. It adjusts in Z and it adjusts in Y. Now there is a difference in weight. That was, as we found out, 130 grams, and this is about 180 grams. So it's about 50 grams heavier, but I don't think that's going to be a major effect on the head at all. Now the existing screws in here are, I believe, 16, yes, they're 16 millimeters long, M4 by 16. I think we're going to have to change them to M4 by 12. This plate sits on here. It's got a couple of location bars on the top there to stop this from twisting. All right, and that will slide backwards and forwards. Now, I've made, I think, one small mistake when I designed this, and that was to copy exactly what was there before, more or less. If we notice here, these screws line up with the green plastic of the wiper section on the end of the bearing. I think this probably should sit a little bit further forward without any consequence, so that I could allow these screws to pass through and sit out in fresh air, because at the moment they've got to be very accurately sized so that they don't poke through very far at all. Now, depending on your machine, we have to take this into account. We've got to allow a flag out here to cover the sensor. So that's what this sticky out piece is all about. Now, your sensor might be at the other end. It might be, for instance, here somewhere. The chances are that your sensor will be somewhere like this as well. With this style of head bracket, they usually detect on the underneath face, just here. And so there's a pretty fair chance that yours will be in exactly the same spot. Right, so operation number 1 will be to put the belt, clamp the belt onto this little pad here. Because I've thinned out the material here, this pad needs to be thick to allow me to put the belt in exactly the place that I took it off of. They won't fit. They're at least 2 millimeters too short, and those are 8 millimeter screws, so I need some 10 millimeter M3 by 10 to fit in there. Now I haven't got any cap head screws, but I've got some M3 by 10 crosshead screws. So that's that little problem solved. While we can see what we're doing, we'll fix this piece back on. Now you'll find that when you take this off, it's probably got 2 lock nuts on it. You don't need 2 lock nuts on there, you only need 1 lock nut. So I've dispensed with the extra lock nut. And these should be, again, these are M4 screws which should fit directly in these tensioning holes here. Okay, so once we've fitted these tensioning screws, we can tighten them up so that the belt feels pretty tight. What we're looking for is to make sure that these 2 screws look approximately the same distance. We're looking to get a fairly even tension on this belt. I've got the screws lined up quite nicely in there with the bearing block. And now I should be able to just drop this piece on here, like this. The screws that came out of there are 18 millimeters long. Because I've used thinner material, 18 millimeters are going to be too long. So this time what I've done, I've reduced the screw length to M4 by 12 millimeters long. I've done the screw up fully and it's still adjustable. So 12 is too long. It probably needs to be 10. Right, we've managed to find some M4 by 10s. You just slacken off the screws a little bit. And we should be able to slide that backwards and forwards for adjustment. Now this is the head mounting bracket. We shall just remove this for a minute. And I think it'll be pretty obvious which way the head fits on. And they're the existing screws that mounted the head. Now you will find that there's a small amount of clearance at the back, just so that there's no chance that the mirror is going to jam on the back plate. I've purposely left about a 1mm gap at the front here for a very good reason, which I will show you in a few moments. Okay, we'll leave those very slightly loose there, so that we just adjust this one back screw at the back here, and we can lift this up and down, knowing that the front is not going to wobble very much. We just take that up just to take the slack out of it, just so that it slides up and down smoothly but doesn't twist. And then we can just use this top screw at the back here to set it with. So I've just caught that top back screw at the moment, and I've cut myself some large paper targets here. Now these are not designed for this particular purpose, but I'm going to use one of these at the moment just so that we can get things lined up. My bracket purposely fits the support bracket for the cable chain. The whole design is based on this plate, and there's a limited amount of places that they can actually put these fixing holes. So there's a good chance that your cable tray or your cable chain will be fitting in exactly the same way. Okay, so there's the cable chain fitted on nicely now. Everything's back together. Almost. Slide this through here, between, and we need to just clamp this with a tie wrap. We can clamp that onto this tensioning screw. No power. If there was power there, it would be black in the middle. Right. So what we've got to do now, roughly, quickly, is we've got to pull this out like that. A bit more. Too much. So that's on centre. So we can just lock one of these screws up. Well, we just put the two diagonal screws, we just tighten them up very, very lightly, because they've got to come undone again in a minute. And now we've got to get the height right. Well, we've just got to lift this up to catch the beam. So we'll undo this one screw, and we'll lift it up. Well, there we go. I don't think we could ask for much better than that. How long did that take? A minute? Okay, so we've got the head set up approximately. All right? And for most people, they would say, that's Z set. All I've got to do is fiddle with my screws on the top here and I'm job done. Well, we know that that's not the case, because now we've got to make sure that the Z axis is perpendicular to this table. And what I'm going to do is put a block underneath here, and I'm just going to take any piece of card, I'll use one of my discs, and we're going to do a pulse anywhere, it's not important. Now we're going to drop the table down by at least 4 inches, 100mm. Any more, it doesn't matter. The bigger the distance here, the more accurately you will set the Z. And now we'll press and have another pulse. And there we go. It's wrong. Now to correct that back to the first pulse, what I'll have to do is to undo this mirror, let the beam swing that way. Let me check it again. Maybe. So we've got it near enough. We've got to go through the whole process again now. And here's our second attempt. It is very, very slightly towards here. So we want to let that mirror go that way, so we'll let it off just a shade more. Too much, I think. I think that's pretty good. Now, because it is so easy to do, we'll just carry out one last test. So we've now got the beam running absolutely perpendicular to the table. The next challenge is to get the beam in the centre of this axis here. I've made myself a very simple little jig that is a nice snug fit. It's a slide fit. I was very lucky with the way in which I cut the dimensions. That allows me to line this up, this little square box, with the axis of the tube. And this is really what I designed my targets for. My targets just sit in the bottom there, like that. Now, it doesn't matter where the head is now. All I'm trying to do is to get the spot right into the centre of those crosshairs. So let's do a quick pulse and see where we are. Well, there we go. We can see that we're not on the crosshair. All we've got to do is move the head backwards, and that dot will come into the middle of the target. So we just loosen those screws off on the head, and we gently move the head backwards and try another pulse. Bit more. It's not bad. I don't think I've even got to move the head up and down. I think I'm that lucky. So we just drop another target in and do a quick pulse test. Well, I don't think we can ask for much better than that. We've adjusted things easily in this backwards and forwards plane. I'm a very lucky guy, and I think maybe I ought to go and do my lottery numbers now. They happen to come out spot on that centre line. 8 people out of 10 would say, great, you fixed it, leave it alone. No, I want to show you how easy it is to set this head up. So what I'm going to do is drop the head down and we'll do another burn. And that's what happens when the head is out of position vertically. You can see I haven't affected it backwards and forwards. It's still on that centre line, but now I've got to get it onto this centre line. Now, this is where you might need some mental acrobatics. Look, if I put that there, in line with my mark, it's forward of the centre line, which we can see. But if it's forward of the centre line, it means that the beam is coming in and hitting the mirror too high. It's hitting down in front of the centre line. Now, by raising the mirror, what we've done, we've allowed the beam to hit the mirror lower down. And hitting the mirror lower down brings it closer to the central axis of this lens tube. So let's have a quick check and see what we've done. And there we are. Now, I haven't got these screws tightened up on the head, so I think maybe I've still got to put a small adjustment in the y-axis to get that true now. So let me just tighten up the z-axis so that I don't get any movement in the z-axis anymore. So yeah, in a few moments when I get the machine set up, I'll show you how I produce these paper targets. So the goal of this has been to get the beam to pass right through the central axis of the lens.